Alright guys, and welcome back. So we are now going to be doing a fun little project, which is a miniature CNC machine. Strictly speaking, it's a CNC machine again. As I mentioned in the project update just a little while ago, I would avoid saying CNC machine just because a lot of people associate that with CNC mills and whatnot. And this is what I would refer to as a 3-axis, holy cow, my brain, it's not that late already. 3-axis motion control system is what I've been referring to it as. Basically, it's just motion control. It does some stuff with tools is the intent, but it's not going to be milling it or routing anything. So we're going to go ahead and get that out of our mind right now. And to start off with, I would like to go over some expectations. So I have pulled up here very many examples of miniature CNC machines. Actually, I didn't want to start with that one. I wanted to start with one that looks like what we're going to be doing. So here we go. I like this angle better. So we are going to be making a 3-axis system. We're only going to do 2 axes to start out with because the tool is going to be spring-loaded for the first application, so we don't actually need the Z-axis. So we're not going to be bothering with the Z-axis. We're only going to be doing the Y and the X-axis for right now. The Z-axis is easy enough to add later. What you're looking at right here is a very, very cheap 3D printer. And this is the style that we're going to be going for. We're going to just have one Z-axis, not 2, to stabilize the other side because it is so small and should be so lightweight that it shouldn't matter. It shouldn't be that big of a deal. Now, as you can see here, let's look at the anatomy of this a little bit. This is on a sling bed. I think everything that I've seen so far is on a sling bed. And by that, I just mean that it has a Y-axis that does not have the X-axis on it. It moves the Y-axis completely independently of the Z and the X-axis. So basically underneath here, I don't know how well you can see this, but we've got some rods down here to guide it. These are assumably 8mm rods. This machine, I don't know, it may very well be smaller rods on this small of a machine. Not entirely sure, never owned one of these before, but we got some rods down here to help guide it. The bed leveling, irrelevant at the moment. We're not even going to bother with that, but inside here it has a belt, and that belt goes to a stepper motor in the back that you can't see right now. And that stepper motor just basically moves this bed a small distance because, again, it's a small platform machine, forwards and backwards. Over here on the left, you actually see in this machine, they're actually using a belt on the Z drive. That is very uncommon, but because the machine's so small, you can get away with that. So they've got a belt running the Z drive. Here's the belt stepper, or the stepper motor for the Z axis rather, right here to drive the Z axis. And that connects to the X-axis, which has its stepper motor right here on the Z-axis. So the Z-axis is moving that stepper motor up and down. And again, this is a belt system with rods. So all this whole entire setup is every single last component, rods to help guide it, and then a belt system to move it. And then whatever nozzle you put on here, whatever tool you put on here is what it is. So that is a very simple example. Let's move on to some other examples so that we can get some other ideas. Ignore the desktop. Actually, the desktop is something you guys are well familiar with, those things on the desktop. So next we have actually, let me skip over to the Prusa, just because the Prusa is the next most similar to that one. So as you can see, the Prusa is same exact deal here. We've got the sling bed here with the rods, the 8mm rods to guide it. It's using extrusion to stiffen up the base. The other one was made out of completely injection molded plastic. This one is using I'm assuming these are 2020 extrusions, but may not. The rods are running on linear bearings, which have the bed. And then the bed, again, the belt is not modeled in here, but the belt goes from this Y-axis drive stepper motor and then through, and it just slings the bed back and forth. Again, same exact deal as the other one. We have the X stepper motor right here mounted to the Z stepper motor. And then we have this, which is a lot more typical. Now, this is a third-party model because Prusa did not provide a fully assembled 3D model on their GitHub. So I had to track down a different one made by somebody else. I'm assuming he's using all the parts from the GitHub. He just assembled it for us. But for whatever reason, this is not actually modeled as a screw. This is a lead screw right here, and that's very typical. It is very typical on the Z-axis to have a lead screw. And you can see what Prusa did in this one is they actually put the Z-axis motor, stepper motor, upside down, which is completely viable. There's nothing wrong with that as far as I'm aware. But most of the time, the Z-axis motor will be at the bottom. I imagine... I'm trying to think if there's a really good reason not to have it at the bottom. And I actually can't think of one off the top of my head. Again, I don't own any of these machines, otherwise I might just show you mine in person, but I don't own any small format machines, which is why we're building one. Otherwise, yeah, I mean, I can't really think of one off the top of my head. This extrusion right here is to stiffen up the Z-axis, so even though we have the rods right here to guide it, they added an extra support structure. I already closed the browser window for the Easy 3D mini printer thing, but that did not have the extra support from the extrusion. Otherwise, the x-axis, again, stepper motors right here, moves the x-axis back and forth, once again with rails to guide it. So that's all very simple. There's just an idler in here that the belt goes around. Just for the record, this motor back here is the boated tube motor. This is the, what the heck you call it? The extruder motor. This is the extruder motor back here. We will not be having one of these again because, again, I already have 3D printers. I don't need a 3D printer. So we were not going to be putting something to feed plastic into this printer. That's extraneous. Otherwise, one of those things, again, they have these linear bearings on here. Just for the record, I'm not planning on going with that route. So let's move on. Ignore that one for a moment. I'll come back to that one. So here is another one. This is probably the next similar one. This is a monoprice printer that I found a model for, and it's set up very much the same. The one big difference is that this is not using extrusion. You can see this is all bent metal. It's all formed metal, break form metal. So everything here is actually just bent metal. It's not extrusion. Otherwise, it all functions exactly the same. It's got rails guiding and then belts. And on the Z-axis, once again, a lead screw. The one weird thing to mention about this guy is, as you can see, they went for this. It's not quite, let me hide that guy here. It's not quite a Y formation here. Basically, the X motor, the X stepper motor, I'm assuming gets mounted right here. Again, don't have one of these machines, so I can't confirm, but let me turn the music on really quick. Just realized the music's not on. And just realized my headphones never attached, which is why I didn't notice. So anyway, as I'm getting my headphones attached, oh no, my headphones are attached. The music was just taking a while to start on. Okay. So I'm assuming this is the X motor right here mount. So the X motor goes upside down here, and that is in line, as you can see, with the X axis, which makes sense. I guess they didn't put the rods in line, like rod here, right, rod here on either side of it, because they didn't want to box it in. I don't entirely know why that's a problem, but they did do this a bit differently, and I felt like it merited pointing out that they ran this a bit differently. Otherwise, again, it functionally is very similar to the Prusa and the Easy 3D. Now, for the Snapmaker, close that guy, don't save. Snapmaker. Snapmaker is a bit different. So first off, we have these extrusions, so everything's on extrusion, and the extrusions have these plates that keep them in line, okay? And I could not, because it's not modeled in here, I could not figure out how these were being how the motion was being controlled on these guys. So I actually looked it up. I did a bit of research into it. It was a bit difficult to find, actually, but evidently each of these are lead screw driven. So evidently inside of each of these holes right here, these whatever you want to call them, I'm assuming there is a threaded nut. I'm assuming there's a threaded nut inside of there, and the lead screw drives every single last axis, which is a bit interesting. Now, the other thing I couldn't confirm is whether or not there are bearings on the inside of this, because if this is just metal on metal, that sounds a bit sketchy to me. I'm guessing that there's bearings in there, but there is not a lot of space in there. I mean, ball bearings, sure. You could probably fit ball bearings in there, but I could not find anything confirming that. So this is a very interesting printer to look at because A, it uses lead screws on all axes, and B, it doesn't use rails, like linear bearings with rails, or V-rollers, or linear block bearings. It doesn't use linear block bearings either. So as far as I can tell, again, maybe these are actually linear block bearings inside here, but it doesn't seem to use any of those. So it's a bit interesting as an option. You'll also notice that, oh no, actually, I was going to say this one doesn't have bed leveling. It evidently does. I just was looking at the top of the bed here, and it looks so thin that I didn't think that it had bed leveling, but it has itty bitty leveling knobs, so it could do a little bit of bed leveling, evidently. Again, bed leveling, not really so important for us right now. We can add it in later. So that is the rundown of all the machines that, we're basically going to be working from. The general concept where we have y-axis independent of the x and the z, and then the z-axis will move with single z-axis, most importantly, just one z-axis, because our machine's going to be so small that we're not worried about the deflection on the far end. And then the x-axis gets moved up and down on the z like normal, and the x-axis is driven, the rest of the way. Anyway, simple stuff. Again, not a printer though. We're not building a printer. I already have those. Don't need any more. This last one I wanted to bring up just because we're talking about design systems. So I actually designed this off of the mostly printed CNC designs that you can find online. V1, I believe, is the V1 Engineering, I think, is the company that, or the corporation, the group, whatever the heck it is. I don't know what its legal status is, but the organization that heads up, that published the idea first. Let me put it that way. And the interesting thing about this is that it runs on conduit. Now, having done this whole entire project with this conduit and designing this myself, I'm not entirely convinced that the savings are really worth it between extrusion and conduit. The fact of the matter is, on top of the extrusion not being as expensive as I think it maybe once was, again, I bought that box of 8-foot conduit, 8-foot extrusion for a pretty reasonable price. The per foot price on it was not bad, not something I bulk at. The overall price just to get it all shipped down was more expensive than I would have liked it to have been, but when you break it down to the per foot price and the fact that most DIY things you're going to be building, with the exception of obviously that router sled I made, which is a lot larger than 2020 extrusion really should be used for in general. So for most small applications, the per foot cost is really not that bad. So I don't know for small applications whether or not the mostly printed CNC solution is a great idea. However, it is definitely an interesting idea. Now, for larger applications, I can see it, especially because, and they do it for larger applications. They do full-size router tables, mostly printed CNC. So it's one of those things that makes more sense to me. But for these small-scale applications that I've been using it for, that I tried it out for, rather, the savings really just are not there for it. One thing I will say about this guy is when you go on the mostly printed CNC, if you do look into that, I made a different carriage than they used because I wanted to leave this open. Normally, you would actually have 4 sides to this. 1, 2, 3, 4. I only have 2 sides, and then the x-axis. Okay, and by having 4 sides as I normally have it, you get an X shape for the Z carriage to ride on. So the Z carriage being this part right here, and that would move the tool up and down. I was not actually putting a motor on here to move my tool up and down. I was keeping it at a constant height, and therefore I didn't need anything really, and I just went with this because this was a lot simpler. So for the record, if this looks weird to you, that is the reason why. I had my reasons not to set it up in the way they normally set it up. This also, I'm using, I think, 0.75 3/4 of an inch conduit, whereas they normally use 1 inch conduit, just because, again, my application was small scale and I didn't really need the to prevent the deflection as much. Actually, let me hit the inspect button right here. Diameter 0.7. That's interesting. So diameter, so it's probably 0.75, and that's the nominal. Back to construction materials, for some reason, have a nominal that is larger than the actual size. So I'm guessing that's what the case is that this is 0.75, but that's just nominal, and it's actually a little bit smaller. So anyway, that is the introduction. And again, I just wanted to bring this up because it is a very interesting idea, and I was very interested to try out the mostly printed CNC option. Again, with my own take, obviously. I made some serious modifications here. But at the end of the day, I have decided for small scale projects to stick with extrusion and V-rollers for the most part, and then belts and what do you call them? Threaded rods for motion. So yeah, that is the whole entire setup to this project. As you can see, the project is empty right now. I have, however, grabbed everything I could think that we needed over here. The only thing that I did not bring in, and I just closed the other one, but in my kit, I bought a kit when I did that mostly printed CNC for G2 pulleys and etc. And that has a little clamp for clamping the belts. And that clamp for clamping the belts is, in my opinion, more convenient than building in the tensioners into the into the ends of the rails. So it's one of those things. I don't have that model right now because that was not actually saved as its own component. I actually modeled that up inside of that mostly printed CNC style machine that I just showed you. So I'll have to get one of those. I plan on using those again just because I have them and they're convenient. But I do not have the model right now, and it's not that big of a deal to not have it right now. We can skip that and come back to it. And also, to be fair, it is, I think, something like 1.5 inches long, something like 30 to 35 millimeters long, which at a small scale is not insignificant. So even though I'm sitting here saying I'm going to use it because I have them sitting around, I have extra sitting around, I may not. I may actually go and just 3D print, the tension and the capture of it into the model itself, just to save space. So yeah, let's get started then. I'm just going to go ahead and insert in some extrusione. Okie dokies. And let's see where our origin is. So one of these things, I guess we just start with the y-axis. That seems logical to me. So let's go ahead and create a new component, y-axis. And I'm starting with the y-axis because it's closest to the ground. So I'm just building up, for the record. Some more coffee. And let us go ahead and boundary fill this guy. New component, select cell. Okie dokies. So now the y-axis has the start of its this is currently center right now. Now on the width of the bed, we want the width to be shorter than the length. I was talking about this during the project update video that I just did an hour ago. Well, a little over an hour ago at this point. And I said that, okay, we're looking at something like 6 wide, 8 inches long. The reason you want the width to be the width, assuming, actually, I should probably turn and look at it like this, since this is how the XYZ is set up. So from the front view, the width here, you want that to be shorter because we only have one Z-axis. So you want that to be as short as possible, so you have the minimum amount of deflection off the far end. So that's why we're making the 6 inches this way and the 8 inches the other way. And again, that is our travel distance is what I'm looking for there, which means that we actually need it a bit further to also encompass the stuff moving it, like the brackets and whatnot. So anyway, with that introduction out of the way, let's get this guy lined up on this side. Try to grab the middle here. And I want him, let's turn him off really quick. Try to get, there we go, like that. And rotate you, nope. Flip you, nope. Okay, we're just going to keep you there then for a half a minute and realign you so that you're standing up. And let me turn the original off so that I don't have to stare at it. There's that. And now we want to make sure that you are also level with the ground. All right, there we go. So now you should be that's interesting. It did not actually get centered on the center point there, which is a little bit annoying, but we can fix that. There we go. All right, now you are completely centered with the exception of the ground, and we can go ahead and get you into position. So what I am thinking is okay, I think I do want the bed to completely cover up the Y-axis extrusions. So we're going to go ahead and move this guy. Let's capture position really quick. Going to hop up here. Come back here. Y-axis, just because of the way Fusion handles the timeline here. And I'm going to go -3 inches this way. So this will be the outside of the bed. Again, the bed itself will be 6 inches altogether, so that's 3 inches from center. And this is not our travel on the x-axis because we need the center of our tool plate of the x-axis to be able to reach here. So that's something important to keep in mind. So if I hop forward to end, and got to come back up top in order to get there. Let's hop back in here and now modify this so that the outside of that is up against that. So again, this plane right here is the edge of the bed. So I want the extrusion to be hidden by the edge of the bed. That's how I want to design this right now. And now, since this is centered, we can go ahead and extrude this out. Now, again, this technically is going to need to be longer, but to start out with, I'm going to extrude it right now, and then we will adjust the length as necessary. So, from object, I'm going to use the center point, and then we're going to symmetric, because I want the overall to be 8 inches. 8 inches. And this will be a join. And technically speaking, I should be inside here. So let me hop back a second. Just pretend we didn't screw that up. Extrude the face from object center, symmetric, overall 8 inches, and join. Inch. There we go. And join. Okie dokies. Awesome. Groovy. So there is the start of our left extrusion. We can go ahead and create Actually, I'm going to wait to mirror it because we don't really need to mirror it just yet. Because we are going to need to extend it out a little bit further than that. So let us move on to the next thing, which is getting the motor in here to move the bed. Actually, no, let's do the bed next. Yeah, let's do the bed next because we have the height off of this. I'm just thinking, should we do the bed next or should we do roller? We can do rollers after we do bed. Nah, we should do rollers next. I take it back. All right, let's get the rollers in here. So we're gonna create the bed right now, but the bed is going to have rollers on it. So again, the bed is not level at this point. It's just going to be a flat piece on rollers. The way I wanted to do the rollers for this design is a little bit different. So before, when we did the router sled right, we had rollers on either side of the extrusion. I actually want to try this because we're going to have two extrusions opposing each other, and it's a small distance, a relatively small distance between here. I actually want to just put rollers here and over here on the opposite side. And the trick there is that is going to make it difficult to adjust the tension, adjust the eccentric nut on those rollers, but it means we only need 4 rollers if it works. That's an if, you know? If it works, we only need 4 rollers, and it keeps the bed within the bounds of the extrusion, so only the bed plate itself will be hanging over the extrusion. We won't have extra rollers be on the extrusion, which saves us on space. So I'm experimenting with this, and hopefully it works out. So let us go ahead and get that started. I will go ahead and let's see, how do we want to do this? I think what I want to do is get the mid plane here, put a sketch on the mid plane, and then work off that sketch. Attempt to get a mid plane here. Oh, that's a tangent plane. That's why I can't find it. Offset plane. Or no, not offset plane. Mid plane. Derp. So I want this mid plane. I'm going to put a sketch on this mid plane. This is Z mid plane. And then I'm going to align the rollers up to the sketch. The rollers and the spacers. Did I bring spacers over? I just have the eccentric nut right now? Okay. I will have to grab spacers then in just a minute. We can fix that in a second. So let me go ahead and grab that wall. Okay. Look at, turn left extrusion off. Toss these guys in here. Determine their spacing. Let's say, so actually we could do, I was going to just do 4 rollers, but we could do more than that. We could do 3 rollers. We could do 4 rollers if we really wanted to. The question is, how much is overkill? I guess I'll start with 3 and we'll, let me start with 2. I'm going to start with 2 just to see how bad it is, and then we'll go from there. So what space do I want on 2 rollers? If we have an 8-inch bed, then I want to say 4 inches, so about 100 millimeters. It's technically more than 100 millimeters, but that doesn't necessarily matter. These were M5 spacers. Well, M5s on the center. M5 bolts go through them. M5s. And the wheels, let's pop open the wheels really quick because I need the diameter on the wheels. Diameter on the wheels are 24 millimeters. So we need an outside diameter of 24 millimeters, and we can, because we're not extruding this can just be a construction line. 24 millimeters. We'll make that tangent. I could mirror this, but I am going to opt not to, especially because I will, however, change this from being 5 divine to being equal, because we might be adding more, right? So I don't want to deal with that later. I do, however, want to make sure that these guys are parallel to that and that they are centered on that. So let's grab the center point, and make sure that is at a right angle. Not unlock you, unlock you. I want you to be at a right angle. And these are all just construction lines. And technically speaking, this, I'm probably not going to extrude this either, but I'm going to leave it solid for right now. So that should be the placement of my wheels right now, and I can use that to place the rest of the stuff. So let us do I need to do anything else? Actually, you know what? Control Z. You know how I said this was tangent? I will go ahead and do 25 here instead. And the reason I'm doing 25 is because, again, with the router sled, I gave myself an extra millimeter, I think, of wiggle room. Again, we're going to have the eccentric nut on here, so the eccentric nut can either eat up or, well, it only really eats up. I can't remember whether or not it will go in and out half a millimeter or not. It's been a while, and by a while, it's probably been like a month. But regardless, now we can bring in the view rollers. So let's go ahead and insert these guys in here. Okay, get you aligned. We want the center of that guy. Center of that on that guy. Cool. Look centered. Does not look centered. Oh, that's right. This is 2 bearings in here. That's why. So I actually want to do my rollers have a construction line for their midplane. They do. Okay. So let's go ahead and modify, align. We're going to get the hole lined up first, and then we'll shift them up with that construction plane. That construction plane to, where's my mid plane at? Left extrusion, Z mid plane. And it did not bring the it did not bring the whole entire component with it. Excellent. Excellent, excellent, excellent. Let's see really quick. Let me turn this guy off. Are these guys pressed right up against each other? They are pressed right up against each other. Okay, we can do that then. Instead, we will modify align and come in here and grab this bottom edge of this guy. So let me turn the sketch off really quick. Sketch off. And let's do this. Find this face here. I think it's that one. Nope, it's not that one. Okay. Oh, bother. All right. Hop in here. I should have designed this a bit better to make... Well, honestly, that plane, I'm a little confused why that plane isn't doing it for me, but regardless, I'll complain about that later. So, modify, align. Now I can see that face. That face now can come up here to this plane, and we are now groovy. So now we're right in line there. Capture position, bring another one in, insert, and we'll just rinse and repeat. Modify, align. The center of this hole on that hole. And then turn that wheel, pop this guy open, turn that off, modify, align that face to the Z-plane. Okay, and there we go. Now we just need those spacers. I'm going to put the eccentric nuts on the right hand side because I'm expecting the Z-axis to be on the left-hand side. So the eccentric nuts, I went away from the Z-axis just because, again, this is going to be hard enough getting to them to adjust them because they're on the underside, on the inside, which means that we want to limit as much difficulty as we can. Regardless, let's see. I guess these, I probably called them M5 spacers, so let's hop back up here. Search. Try to kill the search. Evidently I can't hit that X button. M5 spacers. Trying to see around my camera right now. Get the camera out of the way because we don't need it. M5 doesn't work. M5 spacer rather doesn't work. Huh. I wonder why I don't have M5 spacers. Fascinating. Okay. We will just have to make that then. So let us go ahead, components, capture position really quick. Just make this guy up. I'm going to, actually, you know what? Do I have an M5 space? I should have an M5 spacer right here. One second. Where did I move those guys to? Evidently I moved them. For the longest time they were right next to me on the shelf here, but it looks like I might have moved them. Not down in the electronics box. Let's see. Huh. What could I have done with... No, those are collars. Oh, but are these? Yeah, there they are. Yeah. Because I was digging around with my springs, because I did the spring for the joystick. I moved my spring stuff, and this stuff was buried underneath the spring stuff. So here we go. A little bit of bag crumpling ASMR for you. There's the spacers, so let's get this modeled up really quick. It should be 5mm on the inside, so I'm not going to bother with that. Actually, maybe I will just for sanity's sake. Yep, 5mm on the dot-ish, assuming that my calibers work. 8mm on the outside, and 8mm tall. Alright. Circle, 5mm, 8mm, extrude 8mm, symmetric, overhaul. Okay. We'll leave them steel. That's fine. And actually, you know what? I'll make them aluminum. Aluminum. Do I have a preference? Satin. All right, it's satin now. And we go ahead and save this guy. We can save it in components. That's fine. Close it. Make that read only because we don't need that anymore. Yep, make it read only. Yes, please, please, please. And let's get these guys in here. And we are on bed right now, right? Yep, okay. Insert into drawing. Modify align. That on top of that. Okay, bring the other guy in. Insert. Okay, modify line. That guy on that guy. And okay, capture position. And now let us go ahead and turn the left extrusion back on. We are above the extrusion, that's good. I wanted to double check that just to make sure I wasn't going crazy. The placement here, as you can see, is clipping, so we actually need to move that back, evidently. No. Okay. Yeah. I was stupid here. I took this inside wall. It's never going to hit that inside wall. This edge right here should be hitting this wall right here. So that's the wall I should have grabbed. So that was my stupid. So let's come in here. We're going to delete this line right here, delete the tangent, and then reproject out that wall and turn the extrusion off so we can see what we're doing. Kill that one. Kill that one. That's the bottom half of the wall. That's the bottom half of the wall. And then retangent these guys. And we should be good to go. That parallel to that. And then the center line. Center line to center line. Make sure it's a right angle. Everything we did before. Try to select that and make it a construction line finish. And then we just need to realign these guys. And these guys are already vertically realigned, so we don't have to worry about that guy. We just got to, let's see. Is this my first wheel? Nope, that's not my first wheel. That's the extrusion. So find the first wheel. There's the first wheel. Align. And again, we just need to align the, the centers. And it did move it down, unfortunately. Is there a way I can do this without moving it down is the question. Let's see if I can't do this. Yeah, that was the more intelligent way of doing it. So the outside, I should have thought of this before. I don't know why I didn't. That's called me not thinking and hurrying and etc. Obviously the outside of the wheel is going to be able to give me a midline, so I didn't need to go off that center plane. Should have just taken a second to think about the problem, and we would have been good. So again, the center of this, just going to go to the center of that. And me moving my mouse instead of just accepting what it's selecting because it's smarter than me. There we go. And finish position, and then you guys. And you guys, fortunately, are on the same positioning thing, so I don't have to worry about doing this anymore. There is that. And modify align. There is this off center? It shouldn't be off center. It shouldn't matter whether I click this one or the other one, but, and by off center I actually meant vertically different, which is not what off center means, but you understand what I'm saying, so I don't have to explain myself. Alright, there we go. Now everything, alright, and there's my extra millimeter in there. That's why we have the gap there, and that's fine because again the eccentric nut will eat that up hopefully, and if it doesn't, well, a couple solutions. One, I can put eccentric nuts on both sides, so eccentric nuts here and eccentric nuts over here. Otherwise, if it we can always just come in and readjust. You know, we can just readjust the base to hold it, or to be positioned correctly. So that is that. And by the base, I actually mean the extrusion. This extrusion probably is, we can probably adjust that. I mean, it depends how we put it together. But if we put vertical pieces, or I guess x-axis pieces, so here's my x, here's my y-axis right here, right? If we're looking at the origin. If these pieces that are running this direction are the long pieces, and then these guys fit between those two, if that's how we build it, then we can adjust these legs in and out to fine adjust it if the eccentric nut do not take up enough space. So next up we want to, so that's the wheels for the base, so we can start drawing the base right now. Actually, yeah, I think I will draw half the base and then we'll mirror over the other half of the base. And the reason I'm going to do that is because we need to figure out where to put the motor. The motor needs to be behind the y-axis, or is typically, I should say, behind the y-axis. You probably can come up, whoops, that's not examples. Let me just open one up so that you can see what I'm talking about. So this is behind here because this is only going to be able to pull this base just so far, right, to the back before the belt ends up past the limit switch goes right here, right? So as soon as the limit switch trips this thing, that's where it's going to stop. So if it was further towards the center, if this was further towards the center, that would be a problem because this the limit switch is right here. Right now the limit switch is baked into this back bracket. You wouldn't be able to trip the limit switch if the belt coming around this pulley was coming around the pulley up here, because obviously the belt would hit the back end of the pulley and try to start pulling the bed down and around, right? It wants to follow the belt. So if the belt is making its turn to go back underneath in the middle right here, that obviously doesn't work. So this motor needs to be far enough back that wherever this trips right here, which it should trip off of, I believe, this right here, this face right here, is what I'm assuming the limit switch trips off of. You can see this is where the belt gets captured right here. And again, I may just do exactly what they did here and include this capture of the belt in the 3D print. It's one of those things. I have the pieces, therefore I wasn't going to, but it's just as easy, really, at the end of the day. Regardless, point being is that the belt is further from the limit switch, but we need to be able to make sure that at the furthest back point, this bed, and because of how I'm facing this, is actually going down, and let me come straight right here. So this bed at its furthest point back, okay, so that this nozzle is at the front of the bed, that point has to be before the limit switch and before the motor, consequently. And likewise, well, the front doesn't necessarily matter as much because, again, all that matters is that the front side doesn't, is far enough out. Right now we're trying to get the placement of the motor. So anyway, I'm trying to explain things and I'm probably over explaining them, is the fact of the matter. So if we have an 8-inch bed, we need to get 4 inches forward and backwards from the middle point. So if we need to get 4 inches forward and backwards, the stepper motor can be within that 4 inches so long as the bed overhangs enough and we trip the limit switch a bit earlier. So let's go ahead and bring the motor in. Come back up here to components, bring the motor in, insert, key, and I do want to rotate this 90 degrees. Do I want it facing this way? Good question. Does it make a difference? I think I want it facing the other way. Just because... No, I want it facing this way. Because, again, the eccentric nuts, I intend to only put on this side. So this clears up more space, in theory. So there's that. And then I also want to come up here. Okay, it does not have its own, alignment just yet. So let's hop into here. Bring this up to the floor is what I was going to do. And then, did I make this 8 inches? Let me not select a radius part to make my life easier. And swap you over to inches. I did make this 8 inches. Alright, let's start. Again, because it's a matter of the limit switch, a combination of the limit switch and the bottom part of the base, I'm actually going to go ahead and just put this motor at the back here and see how we turn out. Because again, I want to be able to run the, well, it actually doesn't matter. I take it back. I can still run the extrusion along the back even if we have to extend it. So that part doesn't necessarily matter. So there is that. And then we want, So actually, this is an interesting issue. So let me bring this G2 pulley in here to demonstrate what the problem currently is. Okay, modify align. That actually, we should be able to click the center of this hole here. There we go, and that should be the front side to there. Okay, let's capture position really quick, and as built joints, this guy to that guy, and that is rigid. That is correct. Okay, and to further emphasize my point, I'm gonna hop in. Oh, I can't add it in place. Okay. Oh, actually, let's back up because I did not import that in the right object. So forwards, hop down the bed. Oh, that's interesting. Whoopsies. Let's rename this. Evidently, I saved that as untitled. Good me. M5 spacer. There we go. Actually, let me say 8mm spacer. M5 8mm spacer. There we go. Okie dokies. And now let's bring that pulley back in. Insert into design and align. Modify align. Center of that hole. Center of that face. That didn't, is that? Yeah, okay, that is. Okie dokies. Capture as built joint. That and the shaft, okay. And now, let me, how am I going to do this? Because I can't edit this in place, which is my biggest problem. I wanted to get the center of that pulley to demonstrate. All right, so you're gonna have to imagine this. Actually, no. All right, we're gonna do this. New component. Motor assembly. And I'm going to drag you guys down into here. There we go. Now I can throw a center plane into this guy and we'll be able to do this because it is important. So there's my center plane on the pulley. Pulley center plane, center plane, mid plane. No, center plane is actually better for explanation purposes. So my problem here, all that out of the way, 10 minutes of prep, is that this really should be aligned with, this center plane should be aligned with that guy. All right, well, I'll tell you what. It doesn't want to align right now, but you understand the point. The point is that the center of this pulley should be in our center line because in theory it should be the center of the bed. Now, the funny thing is that I actually don't think that's necessary. I know I put all this effort into getting this to show you, but the funny thing is that it probably is not necessary. So long as it's pulling the bed parallel with the rails, it actually shouldn't matter too much, especially because the bed's so big that it's pulling it at off center. It's one of those things, the rollers are keeping the bed center anyway, so it's probably not that big of a deal. But in an ideal world, we'd want this center plane directly in line with this plane. And unfortunately, that is not going to happen at this point. Because if I do that, and I tried moving the center plane, so instead I'm going to go ahead and do this and then move it myself. That component to that. Okay. And then, well, right now you can already see I was going to move it some more but you can see the wheels are already impacting right here. So that's my biggest problem. My biggest problem is that we don't have enough space to get the center, which means that the width of the bed, in theory, should be wider in order for this motor to fit. Now, one more thing to mention is that the thickness of this motor is specific to motors that I had before that I was modeling for, which is 33.35, evidently, according to this. I think I have smaller motors. Actually, let me pull those back up. I made a copy of it because I was going to Oh no, I'm way in the wrong place. Way in the wrong place. There we go. Give it a second to load. These motors, I think, are smaller than the motors in that model. No, okay, they're the same size. I could have swore these motors were smaller because these were lower torque motors, but evidently they are not. So I guess we're alright with this model then. Again, I could have swore this model was for my higher torque motors, my 2 amp motors, but evidently it's not. So we're good for right now. In that case, I'm worrying for nothing. Let's get back to Mini CNC. Where's Mini CNC? There we go. Alright, so in the meantime, I'm going to go ahead. I'm going to delete this mid plane because it's worthless to me right now. Modify, align. We're going to go ahead and... that's not really going to work now. I kind of want to base it off this wheel, which means that I'm going to have to throw an extra plane in here. I don't really like lining it up like this specifically, but the alternative is to draw a sketch and then line up against the sketch. Or otherwise, actually, I take it back. The alternative is to put a plane against this guy, put him 25 millimeters out, let's say, which is the width that we did here, 1 millimeter plus 24 millimeters here, and then maybe another millimeter, so make it 26 millimeter, and then align to that plane. Which is not a bad idea. Actually, I think I will do it that way because I don't really like having the tangent on the wheel like that. So let's go ahead and do that. And we'll call this the back of motor assembly. Let me put that inside of the motor assembly then, if that's what I'm going to call it. So this is going to be 24 plus 2. I'm going to type it up like that. I could type it up +1 for my spaces. Yeah, let's do it that way. Just so in the future I can look at it if I ever need to change this and go, oh, okay, so this was originally 24. What does 24 represent? Okay, 24 represents the wheel, and then I guess I threw 1 inch on either side of the wheel, or 1 millimeter rather on either side of the wheel, and that's how I got 24 plus 1 plus 1. So back of motor assembly. And we'll go ahead and just line this up to that and call it a day. And by call it a day, I don't mean end the stream, I mean have it in place. The next thing we're going to want to do is design the motor bracket, which is very simple because we have the model right here. Although I probably want to throw... Actually, we have some issues, I just realized. This Prusa over here, I said that I don't know if these are 2020s. I haven't actually checked. These are probably 4040s, is my guess. Let me try that again because I didn't grab 2 planes. What do you say? What do you say? Degrees, angles. These faces aren't parallel to each other? Really? Why aren't the faces parallel to each other? Huh. That is fascinating. Let's see, how am I going to measure this then? If these faces are not parallel to each other. Maybe I can grab these edges? I mean, I shouldn't be able to. The edges should have the same exact problem, but... Maybe take a sketch. Oh no, there we go. Okay, 30 millimeters. My problem was that the way I'm doing this right now, the motor is way bigger than the extrusion, as you can see. And my bed, in theory, is right here. Right up against these spacers is where I was going to put my bed. So that is a problem. So it's not a huge problem. It just means that my stepper motor is going to have to go outside of the frame is what it means, instead of inside the frame. I wanted to keep it inside the frame to keep it hidden, but that is just plain not workable with 2020 extrusions. If I picked up 4040, 4020s, 4040s, whatever, then this would be workable, because that would obviously be taller. Again, this is 33 millimeters right here, right? Is the height that we're working with here. Oh no, that says 42. Oh, 33 was the other distance. All right, yeah. Okay. So 42 millimeters is what we're working with here. So actually, yes, I think the 4040s might work just because these spacers are in there. I don't know. Regardless, we might be able to make it work with larger extrusions, but that is not the case. So we are going to stop talking about it. The only question is whether or not, and it does look like it does look like this pulley right here is above this line right here. So let me line up with the back. Hopefully we'll be able to, we can make it work one way or another. So worst case scenario, the absolute worst case scenario is I move this out and then we have to put idlers underneath the bed to keep the belt down from touching the bed. That's worst case scenario. And that's not ideal because this is already a pretty chintzy setup with just these rollers on the inside here. And that idler is going to want to spring the bed up off that rollers, or bring the whole entire bed with the rollers up off the extrusion, rather, is how I should say it. But we'll see what happens. We'll see whether or not that ends up actually being a problem. So anyway, let's come back up in here, grab this alignment, and let us see. So now that this is all the way outside of the bed, we actually don't really need to worry about the length of this extrusion. The length of this extrusion can actually be 8 millimeters because it actually can be shorter than 8 millimeters. And the reason it can be shorter than 8 millimeters is because, again, the limit switch is only going to touch off in the center of the bed, in theory. Where the limit switch touches off is underneath the bed. The bed can actually overhang the backside and be fine, so long as it does not go past these rollers. So we can actually use that. So these rollers will be our limit switch, basically. Will dictate where our limit switch is. Which means that if I have these rollers 100 millimeters apart right now, then our extrusion only needs to be 124 millimeters, right, for the outside of the wheels. And then we might just want to give ourselves another, let's say, 10 millimeters of breathing room. So if we want to, this can be 134 millimeters is what we can make this extrusion right here. 134. Let's finish position really quick. Right now we are at 203. 203 is what we're at right now. So let's go ahead and experiment a little bit and call this 134 millimeters. So here's our rollers. Okay, that's not going to work. I take it back. I forgot the rollers are spread out 100, but we need to swing the full 100 as well. So that's not going to work. I'm just thinking right now. So the bed's going to be this length. The bed needs to be able to move actually the full. So this 112 millimeters. The 112 millimeters from the center line. Or wait, no. 12 plus 50. So 62 millimeters from the center line is dead space. And then we need to move 4 inches past that dead space. So I think that actually means that we need to have this extrusion be 4 inches plus 62 millimeters times 2 is what I think this extrusion has to be. So let's go ahead and do that. Put these in parentheses. 62 millimeters plus 4 inches times 2. And this is because of the way I have this set up. Let me look at the Prusa really quick. So this is, because this feels a bit long, but I may just be imagining things, 327. Let's look at this. 262. Oh, but you see how close their center supports are? So these bearings are more or less my wheels. They're a little better than my wheels, frankly. But they're only 800 out to out, whereas my bearings are, my wheels rather, are 100 middle to middle. So that would be out to out on that would be plus another 24. So 124 compared to 80. So let us go ahead and bring our wheel spacing in. So I'm going to go ahead and change parameters here. Let's get some parameters set up. Y axis wheel spacing is going to be, let's say, I kind of want to beat the Prusa right there, so I'm going to say 70. It's kind of a petty, silly thing, but wheel V-wheel diameter is 24. Okay, so let's start filling in some parameters. This is going to have to be wheel spacing. Whoops, tab does not work in Fusion. Wheel spacing divided by 2 plus wheel diameter divided by 2 plus 4 inches times 2, so that should be right, but I can't see what I'm typing here, so I don't know where the error is. Plus divided by 2. It might just be a matter of parentheses times 1 inch. Let's try that. Nope. Plus 4 inches does not fix it. Alright, so let us come in here, times 1 inch, put that one in there, does not fix it, times 1 inch, throw in extra parentheses in here. Fusion, you so silly, why can you not read Alright, let's back up and do it in here so I can see what I'm doing. Change parameter. Y extrusion length, and this is going to be Y wheel spacing divided by 2 plus V wheel diameter. Whoops. V wheel diameter divided by 2. Let me take these out to see what happens. Okay, so that works. Plus 4 inches. That works. And then I had this in parentheses before. Times 2. That works. Okay, so that's what I had written, but it didn't accept it for some reason. Regardless, moving on. I'll just copy that over and we'll be good. Y axis, Y extrusion length. There we go. Alright, so that's at 297 right now. And we were comparing to 262. Alright, well, it's closer. I'll take it. let's see. So now we want to, let me bring another extrusion in for the back extrusion. So come up here, components. Actually, that's right. Before I just boundary filled this guy, because it's just a solid block, so there's no special, special relationships. Boundary fill that guy. I guess I gotta turn that guy on. Select new component. Okay. And this is back extrusion. I'm gonna modify a line. Turn this guy off so I can't see him. That is going to be there for right now. We can fix him later. Extend him out later. Modify a line. Actually, we may not even extend him out. He may just make a square. We may just have a square frame right here, because there's no reason for either the front or the back extrusion to be connected to the x-axis, or the z-axis rather. So, yes, capture position. Hit cancel. Capture position again, because I wanted to be inside of the back extrusion before I extended it. And you are going to extend to the midplane. Okie dokies. And now that I have these two guys, let me go ahead and just for fun, where's my corner bracket? We'll go back to y-axis, insert. So this is my model that I made for the printed corner brackets that I put up on printables. However, I will be using the steel cast ones that came with the kit I picked up, because I want them to be more sturdy. The plastic ones work just fine for most situations. However, because this is structural, I want to go with the strongest one I got. And right now I am being a little derpy and not clicking what I want to click, but the derp will eventually be solved. So there's that, and then modify a line. And I based my model, the other thing I should say is I based my model off of the ones that came in the kit. So it should be representative. It's one of these things where actually I guess I should use, it's a little difficult to get exactly what I want here, which is the center line. That with that, no, that's not going to do it, because it's slightly smaller than the extrusion. So one of these things, I guess it's just good enough. I'm not going to fiddle with it, because I don't believe, what I was going to say is I don't believe this wall actually fits. Let me select that face. I don't believe that face actually fills up the whole space. Yeah, you see how there's a gap? So one way or another, I'm going to end up with a gap. So it's kind of whatever. And let's go ahead and never mind. I'm not going to make that a rigid group just yet. Let us just, however, make that black to make it stand out more. Black oxide. There we go. And now back to this motor. So this motor can, let's see, actually let's hop inside the motor assembly and build the bracket first. So the bracket is actually going to be difficult putting it outside, because the bracket, we'll make do. It's going to be a little funny. I'm trying to think, because normally you put the bracket and then you attach the bracket to the extrusion, and it works out a bit differently. But with the extrusion being half the height and it not being parallel with the, or perpendicular to the extrusion, it does end up a little funny looking, especially because we're past the halfway point. which we already knew. Well, I didn't know that exactly, but I had a suspicion that the motor itself would even be past the halfway point with where we positioned it. So with all those factors factored in, I may actually want to mirror this now. I'm pretty sure that this length right here is what we are going to have and what we're going to need to get the full range of movement, which means that I can mirror this at this point. So let us go ahead and start mirroring stuff, and then we'll get the motor in place. So I'm going to come up to the y-axis, modify, mirror, rather create is under mirror, components, that guy left extrusion, mirror it over there, call that right extrusion. I'll leave the mirror on there just to note that it is the mirror. Let's create mirror. That body I got, actually, yeah, let's come into that. Yeah, maybe instead of extruding it like that, maybe I just wait until here and extrude it all the way. That makes sense. And then we can come back up here and finish our mirroring. So we can create mirror that component across the center line, create mirror these components across the center line, and now we can toss a rigid group in here. Create rigid group, do not do child components, just because that always has a tendency to become a problem in the future. And why did we mirror this guy right here? I just realized. Why is that guy part of that guy? When we did the boundary fill, that should have broken that link, right? Shouldn't that have broken the link? Extrude. Mirror. Where'd you come from? Why are you here? Component. Y-axis, corner bracket. Why is the corner bracket a... Does the corner bracket... Oh my goodness, the corner bracket has a extrusion in it. Okay. I guess that's why. Okay. When I designed it, I included a extrusion in there. I probably should go back in there and delete that. Whoopsies. Okay, that explains that one. And then we're just gonna have to come back down here and hide these guys for right now until I fix that. Again, that will get removed in the future. All right. So let us go ahead and position. And actually, I will take this moment to say that we're an hour and 15 minutes, an hour 20-ish minutes close to in. And I said this was going to be a quick build because it's very simple. And I also said that you can always say that it's going to be simple, and it will never actually be simple. I did, in fact, say that. Do I have... I should have one of these motors sitting around spare. There we go. Holy cow, I am pretty sure this is not the same motor. Okay. Back to, I thought I had two different size motors, and this most definitely is not. Yeah, okay. Well, this is funny because this guy on its body depth is 47. And that, okay, yeah, and that guy's 33. Okay. But what I was checking was whether or not there were mounting holes on the back for this bracket. Because I was thinking about mounting it front and back to this extrusion, but it does not appear to be the case. So, that being the case, I'm going to want to come here and then leave myself room in order to... Well, do I really need to? That is the question. I might just be overkilling it. Let us consider. Actually, let me look at my Prusa really quick, because it's right here. Okay, yeah. The Prusa also does not have mounting holes in the back as well. So, and it is like, what? 9:30, I'm not done my coffee yet. I am going to be up late night tonight. In theory. In theory, I'd be up late night tonight, but unfortunately, coffee doesn't do anything for me, so... Right now, I'm contemplating rather, just how well this motor needs to be attached, what kind of torque it's going to have. Looking at my Prusa, it actually doesn't look like the Prusa is attached any other way than on a couple of the screws on the front. So, like, it doesn't even use all 4 screws. And in that case, I guess we're fine like this. I wasn't sure. What I was contemplating is whether or not I should move this out to include a wraparound that holds the back and holds the back T-nutted to the extrusion. That's what I was looking at, what I've been debating the last couple minutes. But it looks like they don't even bother with that. So we will just go ahead and build the bracket and then T-nut the bracket and be done with it. So let us where are we at right now? We're in the y-axis. We want to be inside the motor assembly. Where's the motor assembly at? Motor assembly. Is that under bed? That is under bed. I probably shouldn't have put it under bed. Yeah, well, you make mistakes sometimes, I'll admit. This is where we want it to be placed, I decided, or at least where it's going to be placed at the end of the day. Let's see. Now I'm concerned about it sticking too far out this side for the wheels, but it's gonna be what it's gonna... Oh, actually, I take it back. Okay. Now that we're outside the back of the frame, that's right. Now we can slide this all the way back over to the right. So let us go ahead and do that really quick. Keep up, brain, keep up. So I am going to, again, this is a little bit tricky because I can't get that mid-plane on this bracket. So I'm going to just have to line it by hand. Check what the distance is here. That is 8 millimeters. So now we just need to, now that this is aligned center, we're just going to move component, that guy, translate it, -4, and that should, in theory, mathematically be center. All right, cool. So now this is centered, and we can do that now because we are in trouble. Okay. Let us see. Does anybody notice what the problem is that I just realized? Yes, that is correct. The bed, so our limit switch for the bed is in theory going to be round about this wheel, which means that the bed is going to extend out this way, out past the back of the extrusion by, let's say, 2 inches, which is exactly where the motor is. Again, had I built this up to be a larger base so that the motor could fit underneath it, we would not be having this issue right now. However, we made design decisions that are causing us problems down the line, which is how design works. You decide that you don't want to do something, and then that causes you problems later on. You decide you want to use just the products and the materials that you have at your disposal, and it comes back to bite you because you really should have invested in other products and in other materials that were appropriate for the job. However, things cost money, and you don't want to invest that money. Unfortunately, this is a fact of life. So, and looking at this, it does not look back to, I wasn't sure how this was going to work. It does not look like this pulley makes it over top that extrusion. Now that I have it all the way across. let us see. All right. Solution number 1. Well, several solutions. We have several solutions. One is we just extend this out further and then it needs to go. This outside extrusion. And then this will be inside of the frame, but it will not be underneath the bed. The bed will never cover this up. The bed will crash into the stepper motor if it fails to trigger the end stop. And we're just going to live with that consequence. And the reason we're extending it all the way back is to mount the stepper motor to it. Which is perhaps not a good reason to extend it all the way back. So if that is not a good reason to extend it all the way back, then in that case we can just build a bracket that extends it back, I guess. Okay, at this point, I guess we should do the bed first then to figure out. Well, we don't need the bed actually. We don't need the bed to figure out how far, because we know that the limit switch is going to be tripped approximately 62 millimeters out from the center line, which means that from the center line plus 4 inches minus 62 millimeters. So let's do that math really quick. Should be where the extrusion ends. Actually, no, we already did that math in our 62. Let's see. Interesting difficulties. Right. So 4 inches from the center line is the center point. The new. All right, let me grab a piece of paper to draw this out really quick because my brain is not obviously working. I realized I was going through paper pretty quickly, so I'm trying to reuse some of the back pages. Let's see, one that I have not drawn on from other times I've used it. Alrighty, and let me preview window my camera, since may as well show me drawing. Alrighty. Lights on, and it's one of those things. I got well, alright. Let me move my cup, my coffee, and my water bottle. Get the camera stand in position, and then swap this over to the lift pod to get it closer up, because again, it's hard to see what I'm drawing when the camera is on top of the monitor. So, do this, do that, get this into position. And it is amazing how much lighting changes when I bring this down to my desk. It looks way different. And let's raise up a little bit. Focus camera. Okay, cool. And now we can push this live. Push live. Alright. Welcome back to my desk. It has been a while since you've been here, and like I said, in case you watched the project update video earlier, as you can see, for whatever reason, changing where the camera is, I mean, not for whatever reason, I'm sure there's a good reason, like for example, the direction of the light coming in or something like that, but my hands are not nearly as ghostly down when it's down here on the lift pod as it is when it's on top of the monitor. Actually, I guess part of it could be the glare from the monitor, the light coming off the monitor, the blue light or whatever, could be part of it. So anyway, here is our frame. Our bed, when it's all the way back against the end stop, I'm going to say that's the end stop. is like this, and I'm trying to figure out right now how far back that needs to be from the how far back the stepper motor needs to be in order to not get obliterated by the bed, because again, the bed unfortunately is below the top of the stepper motor. Had it been above this top of the stepper motor, we wouldn't have this problem, but again, decisions were made in the design process. So I know that here's my center line right here. I know that this is 70. This is 70 right here. No, this is 35. This is 35. This is 4 inches. 4 inches. Let me get the actual number, what 4 inches is. I keep on saying 4 inches. Calculator, 4 times 25.4 is 101.6. 101.6. So this is 35 to here, plus 12 for half of the diameter of that wheel. And that brings us to the end stop. So that is the end stop line at that sum, which was 47. I think it was 62 before I changed this to 70. This distance here from center to 70, which will be 35 and a half. So anyway, 47 is our new number, and that gets us to the limit switch. The limit switch, honestly, the limit switch should probably... So right now, in theory, let me just say that the limit switch, the way I have this modeled up on the computer screen, I'm saying that the limit switch is right in line with the back extrusion because we made the extrusion exactly this length. This 12 plus 35 times 2 is what we made the extrusion. So I did not leave any space for the limit switch. The limit switch is exactly on top of the extrusion. Now that is not actually a problem. It might be a problem. It might be a problem, but it is not explicitly a problem at the moment until we actually get the model in there and check. Because the bed, the part of the bed that trips the limit switch, can be right here. It can be right in line with the wheel. In which case, the limit switch would be hit at exact same time the wheel hits the extrusion. That's probably a bad idea, admittedly. Probably a bad idea. But technically speaking, if the world was a perfect place, the limit switch would trip at the same exact time the wheel hits the extrusion, and everything would be fine, and it would stop immediately, and there'd be no momentum, and if the world was a perfect place. So we probably should add, let's say 5 millimeters in here for buffer for the limit switch, and we'll add that on the front side too. So I'm just going to hop inside. Well, no, I'll wait until we get back to Fusion to do that. So let's add this 5 millimeters in. So we are at now 52. So 52 to the extrusion. The extrusion is 20, so that's 70. 20 right here. So that gets us to 70. So we're 70 millimeters out of our 101.6 to the back of the extrusion. So the difference between the back of the extrusion and the back of the bed now is 101.6 minus 70, which would be 28.4. It's math on stream. Again, I always say I don't do math on stream. Let's use our calculator. 101.6 minus 70 is 31.6. There we go. That's why I don't do math on screen. 31.6. Excellent. I am so glad I'm so good at math. Okay. Calculators. What would I do without them? All right. 31.6 is our overhang on the bed. And then we can go ahead and add, round this up to a solid 40, let's say. So we'll put the stepper motor 40 millimeters from the back of the extrusion. And it should never hit in that case. Now we still have a problem with the pulley, the G2 2GT, whatever the heck it is called, belt running over the extrusion. We can fix that. So there's a couple different things. One, let me hop back into Fusion because we're done with this now. So here's me going back into Fusion and not forgetting to change camera scene for once in my life. Let us start out with, I'm going to go ahead and start out with adding that 5mm buffer into here. So this is plus 5mm. That's 307 now. Double check that the model actually updated because I'm paranoid. 307.2. Yep. All right, cool. So now we have an extra 5mm buffer, which is actually not enough because I just realized these corner brackets are in here. Excellent. All right. What are these corner brackets? These corner brackets are 27.75. So we need to stop the wheel before 27.75. Oh my goodness. It keeps on getting bigger and bigger and bigger. All right. Plus 27.75. Okay. There we go. Hoy. All right. So now our limit switch. Well, our limit switch, again, could technically be right on top of the extrusion, and we just change where the plastic on the bottom side of the bed trips the limit switch at, but everything keeps on moving. So let us come up to here, find this guy, get him realigned. Not that guy. That guy. Modify, align. You need to get your face back into that right there. Whoops, not that point though, just the face. Yeah, okay, that's right. Derp. Okay. Derp, derp, derp. All right, so finish that. And then this guy, you need to get yourself aligned. Aligned with that face over there. And actually, you can do the same face because all that is parallel anyway. Okay. Finish. And now we just need to get this guy back. So that changes our math. So camera. So we were at 70 before. This 20 was the extrusion. This 5 was our buffer. So in between here, technically speaking, so in between here is where we're adding our 27 point. Let me check really quick. 27.75. But I'm going to just add it at the top because I can't insert white space on pen and paper. So 27.75, and that gets us up to 97.75. Now this is going to be minus 97.75. And that's going to be a very small number. So on the bright side, our stepper motor does not need to sit back as far, which is good because there's less flex in the plastic because I plan on doing this mount out of plastic. 97.75. So we're at 3.885 right now. 3.85, which honestly, if I do the bracket as, well, technically speaking, yeah, it's just what it is. I'm just going to have to put a plastic buffer in there because it was not going to be up against the extrusion anyway. But that's what we're at. So it doesn't have to sit as far away from the extrusion, which is good. And I'm just going to put a plastic buffer there. Align you to that. Okay. And then move you. Let me make sure that I'm clicking the motor assembly and not just the motor for reasons. There's actually not any real good reasons, but, well, I guess there is. 3.85. And capture, and yeah, I'm going to delete you now. I don't know why that second one came up, what I did with that one to get that one there. Oh, I guess I guess I moved it and then I centered it is what it looks like happened. So I did it in 2 steps, and I shouldn't have done that. I should have re-entered here to align it. Did not happen. As I recall, this is an 8mm gap in here, so this is aligned with 4. Again, we just did this a couple seconds ago, and by a couple seconds ago I mean forever ago, but regardless, that move this 4 minus 4, okay, and now we are good. Alright, back into the motor assembly. Let's build this bracket. Actually, well, yeah, we're going to build the bracket, yes. So the bracket is going to be one part, including the standoff off of here to make sure that we stay away from the bed. And again, we're giving ourselves 5mm of breathing space on the bed anyway, as a buffer room to make sure that the wheels don't hit. In theory. I did switch back over to Fusion. Good. I just double checked my preview window because I did not recall doing that. Excellent. We are becoming pro streamer. This is the motor bracket. A motor bracket. Come in here. Go ahead and do a back extrusion. I want to hop in here really quick just to draw this construction plane. Again, trying to keep things organized. Backside of backside of extrusion. We know it's the back extrusion because we're inside the back extrusion object. Anyway, back to the motor bracket. Draw on there. And the reason I'm drawing here instead of parallel, so in theory, this bracket I'm going to end up drawing like this, but I want to draw the standoff first. And the reason I'm doing that is because I want to get the midpoint here to make sure everything stays aligned, because I'm going to, in case I need to realign this motor, I can now do it off of the bracket because the bracket is being aligned off of the pre-assembled frame here. So it makes it easier to line things up. In the meantime, though, let me hop in here, turn the bed off. Oh no, we can't turn the bed off. Turn everything but the bed off. There we go. There we goes. And turn you guys off for the time being. And I guess I will turn the motor off too for now, because I don't really need it. And I missed an extrusion somewhere. Left extrusion. There we go. Spooky music. I really need to get around to getting some more music. Alright, so here's my center line. That was not perpendicular, but that's okay. Let me project in. Where's the back extrusion again? The bottom of the back extrusion, just to keep everything kosher. And I need you midpoint. That's what I'm looking for. Midpoint to that. And make that like that. Let's see. I actually should have. I don't really need this right here, so I'm going to delete it. We'll make that perpendicular to the floor. And then what I need, though, is the center right here for where to put my T-nuts. So that is that. And back extrusion off and get to drawing. Excellent. Alright, so we are centered here. This is the center line here. I should get, well, I already know. Let's see. The center of the pulley is 4. I don't know what the distance is from the center of the pulley to the back of the motor. The question is, does it matter? I was trying to design this without having the motor here so that I could realign everything up later, but I guess I'm going to have to, just because I want the bracket to extend the full length of the motor. It's technically not necessary, I don't think, because I don't believe that there's going to be enough torque here to twist the motor, but just in case, I do want this bracket extending the full length, and I do want the bracket the full length of the extrusion. It is obviously getting late if I'm making this many mistakes at this moment. Okay, let us grab the top rather. I want it extending all the way to the top. All right, there we go. All right, have all our construction lines now. I believe that is everything I need to start drawing here. So let us get the center point of this guy for our nut placement. That is zoom in, not zoom out. There we go. So there's my first nut right there. Turn construction line off. I'll put it here first and then intersect it just to make sure. That is an M6 is what came in this pack. Actually, I'm not using, we can make those in M5 because I'm not actually using the bolts off of the corner brackets for this guy. So we can just make him an M5. That's one. We're going to need a second one. The question is where to put the second one. We don't want to put it behind the motor because the motor needs to sit flush. So I guess we put it over here, and it's kind of going to be arbitrary. Yeah, it's going to be arbitrary. I can't think of any good reason why it's not going to be, so just an arbitrary 20. And now we can toss this. This is the bracket itself, the standoff plate rather itself. Just make it collinear to everything, and then we should be good. Just have to determine how much space we want on this side. I want 5 millimeters on this side. 5 millimeter wall, I think. That is a construction line, and that is tangent to this wall. And now we can extrude that. And we want this 3.85, again, is what our standoff is. Now that that is in place, now we can switch to the front of the motor. So let's go ahead and we can't edit the motor in place, so this construction is going to be straight off of there. Normally, again, I put this construction inside of the Nemo motor here. Unfortunately, that's not going to happen. So this is front of motor. Draw our sketch, project this guy and that guy, make them construction lines, and now I guess I just make it tangent to this line right here because it doesn't necessarily matter, and I don't want to necessarily be midpoint to this guy accidentally, so I'm going to draw it out over here and then reconnect it. Connect that there, and then we want this tangent to that, and we draw another line up here, have that guy tangent to that, and then connect him up here, and then I will just draw a square to connect everything else. So let us collinearize, collinear, attempt that again. Why collinear? There we go. And then you are collinear to that. There we go. And now we just need to make our mounting holes for the bracket. And I think I will actually include the round part here just to give it some character. Just to make it round. It technically is not necessary, but I like rounder shapes more than squarer shapes. So I'm probably also going to bevel these edges after we get this drawn, but let's get it extruded first and then we'll talk about that. So there's our body, and I will go ahead and, so I'm looking at the Prusa right now. and it's actually looking pretty thick. It looks like the y-axis bracket might be something like 6 millimeters. Okay, more than that, it looks like it's somewhere between 7 and 8 is what it looks like. It's a little hard for me to reach. It looks to be somewhere between 7 and 8. So, let's go ahead and do 7. Well, I don't mind making it pretty thick. Now, let's turn these back on just to make sure that we're not accidentally obliterating anything. We are not. That makes sense. We shouldn't be. And let's consider how this thing is going to be printed really quick. And as it turns out, it's just going to be printed like this because there's no way it's getting printed any other direction. That does mean that I will have to drill these holes out in theory unless I want to thread right through them. Again, we should be able to thread right through them, so it's not that big of a deal. But moving on to these, just making it look a little bit prettier because I would prefer to. I'm not going to prettify this bottom part because this is going to be against the print bed if we're printing it this direction, and it's going to turn out rough if I do. So let's 4.75 I think is what I'm going to do there. And do I round these guys over here? I don't think I do. I think I'm going to leave those corners alone. Just leave them square. Alright, so that is the motor bracket. Let's go ahead and give it a color. Start off with red. Red is a good color to start off with. Red matte. There we go. And now I'm going to come in here to this joint, this rigid, and delete that guy. And we are going to go ahead and rigid group, turn off the child because I don't want to accidentally select the shaft as well. Oh, actually, you know what? I should not have deleted that joint. Right, because the joint is rigid to the pulley. So I should actually just, as-built joint, because as-built joints are easier. Just do the shell to the, or the box, the motor, whatever you want to call it, to the bracket. There we go. I could also have done a rigid group with this bracket, this shell, and the, and the back extrusion, but I think I'm going to, yeah, you know what, that's probably better. I take it back. All right. Yeah, it looks like I did Control Z that correctly, so let us hop up to the y-axis, turn stuff back on, Where is my left extrusion? There it is. And now let's go ahead and rigid group. Turn off child again because I don't want to accidentally get the shaft in here. So that, and that. And there's my rigid group. So these guys are all rigid. There we go. And that, I think, is going to be it for tonight because we're just about to hit 2 hours here. So this has been fun. Again, there was a lot of stuff here. It ended up being a lot more complicated than I expected. And part of the reason it was a lot more complicated than I expected is because I forgot that my 2020 extrusion is extremely small, and therefore the stepper motor does not fit. That added a good amount of time designing around that. Had I been able to just tuck the stepper motor on the inside and not worry about it. Actually, the other thing that obviously took some of our time is the fact that the bed, I only made it 6 inches wide, and I wanted everything tucked on the inside. Had I made this bed wider and allowed stuff to be sticking out the sides, then it would be more feasible to have this stepper motor on the inside. But again, in between the stepper motor being too big for the bed and the stepper motor being off center, you know, everything ended up just getting moved. So when we come back, when we next work on this, which will maybe be tomorrow night, unless I feel like taking a break and doing the joystick or that other project that I keep on wanting to have done. Again, it depends on whether or not the microcontrollers properly work this time and do not explode. Well, do not break at any rate. I broke them. I admit it was my fault. I broke them. But whenever we come back to this, whether that's tomorrow or within the next couple of days, we're going to have to add an idler wheel right here, which means that I may have to change the spacing right here to fit it. Right now, this T-nut right here is kind of in the way. Although it could serve a dual purpose. It could both. No, it's sized specifically for. Yeah, the T-nut is sized specifically for the extrusion, so you can't really fit anything else on here. But the plan is to stick an idler wheel right here to get that belt pulley back over top of the extrusion. So we need an idler wheel here and actually right here as well, which is where the limit switch is going to be. So yeah, well, the limit switch doesn't actually need to be right here. The limit switch doesn't need to be centered. We can move the limit switch off to the side. Things are going to be a little bit messy. Actually, yeah, the wheel stops back here by the bracket. So if we stick the limit switch back here, because this distance between here, all right, we'll look at it when we get there. We will tackle that problem when we get there. All right, that is a problem for another night. We're about to hit 2 hours. So for those of you who have been hanging out on this adventure, again, that, as I said, I was going to say was going to get done very quickly and was going to take 5 times the amount of time that it was going to, and that has served true once again. Again, that is my number one thing I come back to with the DIY stuff is nothing ever gets done in anything less than 5 times the amount of time you expect to spend on it when you're DIYing stuff. It's just something to be expected as part of the hobby, in my opinion, and therefore I don't, mind it so much, which is why I do these things. But if you've been sticking with us, thank you for hanging out, and thank you for any comments you're leaving, and anything else you're doing to, obviously help the channel get exposure. Thank you. And otherwise, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.